one of the M's is muda, which is waste, which is going to be called unnecessary activity. Okay, then the next M is muri, which is overburden. So we'll talk about what these things mean. And then the last one is, what is it called? Mura, variation. So in terms of production, though, we're going to change these things around. We're not just going to call this overburden. I think it's kind of clear what it means. But this is more like you as a developer are overloaded. And then we've got this guy down here, variation. That's not really about variation in product. It's about having an uneven workflow. Okay. Or if we're going to be business people, we just say uneven flow. All right, so from a production standpoint, or sorry, from a developer's standpoint, variation, uneven flow. So what this means is sort of like your productivity will vary a lot when you're in development, because you might be in a crunch scenario where you have to develop a lot of stuff really fast, or you might be in a slow period where there's not a lot of work to do, and stuff like that. So that is bad according to Lean and TPS. You want to have a consistent amount of work to do, and you want to have consistent output, because any kind of variation that's going on is indicating that there's some problem with your production process. So Lean and TPS is really from a production mindset, like producing physical goods, because this came out of Toyota. That's what the T stands for, and then production is production. So it's the P is production. So it's a Toyota production system. So it's all about producing cars and car components. So when you're on this factory and you're producing components, you don't want a lot of variation in the amount of stuff that you're producing. Like if one day you make 10 cars, the next day you should also make 10 cars, and the next day you should also make 10 cars. It shouldn't be a scenario where one day you make 1, and then the next day you make 7, and then the next day you make 23. Right? You want a consistent output. So the guy above, Murray, overburden, overload, is, well, if this is the output we're producing, this is sort of like the demand on our system. We want the system to be, well, we want demand to be relatively constant to support our flow. And we also don't want to have demand be more than we can handle. Because if demand becomes more than we can handle, then you have issues of burnout, and your output's going to start to vary wildly, and it's just going to be bad. Like, you don't want to be consistently asking more than your developers can produce. And then finally, the top one, unnecessary activity. This is what I usually think of when I think of TPS, but it's only one of the 3. You're trying to eliminate waste. So any activities that don't need to be there should be eliminated. So from a business perspective, I'm going to put it in square brackets. This will be activities which do not add customer value. So any of those you would want to try to eliminate. Okay. So you'd identify those and try to eliminate them. And then we'll talk about what customer value means when we get to it. Right, so that's one of the roots of Agile. And then I can't remember if XP came before the manifesto or after, but there was this other thing. There was a big meeting of the big names in software engineering and software development sometime in the early 90s, I think it was. In the 90s, we'll be able to find it when we go read it. But they created this thing called the Agile Manifesto that has 4 values and 12 principles. I don't expect you to remember the 12 principles, but the 4 values are pretty important. So we can just find it by Googling it. So we'll look for Agile Manifesto. Okay, so it has its own website, theagilemanifesto.org. And then they also have a reference to it on the Agile Alliance. So these are the big names at the time: Kent Beck, Mike Beadle, I don't remember him, Alistair Coburn, I've met him several times, Ward Cunningham, Fowler, who wrote the text I recommended for UML. And then these guys were also important. There's Martin and Ken Schwaber and Jeff Sutherland. I believe those 2 are the Scrum guys. And Dave Thomas, not Dave Thomas from Wendy's, it's a different Dave Thomas. Right, so there are the 12 principles listed down here. Let's open it and just take a peek, but I don't want to run through all of them. And while, oh, there we go. Well, anyways, it says, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals in interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. That is, while there is value in the items on the right, those are the small ones, we value the items on the left more. So before this happened, it was very waterfall process centric, where it was super important to have documentation of everything. And then there would be some prescribed processes of developing software, like the waterfall model. And I don't want to talk about tools, but it sort of shrunk the importance of the things on the left. Like this one in particular, contract negotiations, there would be a huge push to get all the requirements specified up front and have them fully documented, and then that becomes the plan, and then you negotiate what those requirements are, and then deliveries around them, and how much they're going to pay for it, etc., etc. And it really reduced all these other things. So if you've got a requirement laid out, and then it's signed and it's been supposedly validated, so the customer has validated it, it's saying, yes, this is actually what we want. But things change over time. Either the requirement was wrong in the first place, because that happens a lot, or the market changes and it's not so relevant, or it needs to be changed somehow to reflect that. Or what happens more often, though, is as you're developing your software, your understanding of what you're building improves. Because when you start out at the front, you don't quite know what it is you're going to make. Like, you have some ideas about what it should do, but then as the software gets developed, understanding improves. The problem is, if you've done all your requirements up front, then you made those requirements before you had that understanding. So those requirements are not going to be great. But if we're in this waterfall model where everything is negotiated up front and it becomes a contract, and then that gets signed off, then when things need to change, it's a problem. Because, well, firstly, a change is always going to cost more money because it is going to deviate from the plan, and it's going to deviate from the estimates built on that plan. So then it becomes down to, well, do we work with the customer to do this change, or do we say, no, you agreed to this, you signed off on it, so we're going to make this other thing? And then normally what would happen is you agree to the change, but then you push all of your dates way back and you jack up the price a lot. And then that's just the ability to respond to change. Do we respond to changes that we discover as we're developing, or changes in the market as we're going along, or do we just stick to this plan? All right, so if you look at traditional management ideals from the 80s, a lot of it is about eliminating variation. Trying to manage a process, if you have an optimizing mindset, you try to eliminate variations in your process. And I mean, that is the opposite of responding to change. Right? So if I'm trying to eliminate variations, then I want to try to optimize my process. And the way I'm going to do that is, well, I'm just going to exploit the existing process as much as I can. And when you're exploiting a process, you're not really allowing for it to adapt. And the reality of software is that when you're developing software, it requires a lot of adapting, because understanding of the problem changes, and even if that doesn't happen, then the market itself will change, and you have to adapt as you go along. Okay. Anyways, that's the Agile Manifesto. Individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. Right, and let's just take a peek at the principles. Our highest priority is to satisfy the customer through early and continuous delivery of software. Then welcome changing requirements, even late in development. Agile processes harness change for the customer's competitive advantage. That's really important, because if the market changes, you want your software to change to adapt to the change in the market. Because if you can't do that, and your competitor does, then, well, obviously they're going to capture the market. Or even if there's no competitor, if the market has changed and you're trying to capture as much value as possible from that market, you have to have your product change to exploit the change in the market. Right, then there's another guy down here about delivering working software frequently. I'm going to keep going until I find the one that's my absolute favorite. And you'll notice it says from a couple of weeks to a couple of months. So this was long ago when this kind of thing was basically heresy. So they had to throw in this couple of months thing. So when we talk about sprints when we get to Scrum, I'm going to recommend a 2-week sprint. But if you're at a very traditional development software environment trying to make a transition to something more agile, realistically, they're not going to go from a 1-year development cycle to 2 weeks immediately. What's going to happen is they're going to have to adopt longer sprints and then try to shorten them. So 3 months might be a good target if you are used to delivering things on 1-year cycles. And it's not unheard of for them to start at a 2-month sprint, and then once they get more comfortable with that cadence, to shorten it. Right, business people and developers must work together daily throughout the project. So this is a point of concern, this daily thing, that really drives up costs. So you only use this type of development for certain kinds of problems, but luckily for us, virtually all software development problems are appropriate for this kind of development. I don't want to get into the SynFin framework, but maybe I'll just pull it up. SynFin, is that how it's spelled? Or is it the other way around? So the SynFin framework is a way of classifying problems. So let me just, yeah, there's a good picture of it. Oh, that one's perfect. I hope it opened. That's on the Wikipedia page. Great. All right, well, here it comes. So I'm going to talk about these in a different context. Is that the same? This one's better. Oh, this one looks good. Let's try that one. So it's kind of about the relationships between cause and effect, but we could also look at it in terms of what's known and what's unknown. So when we're down here with simple problems, we would have what are called known knowns. Like the things you need to care about, you know what they are, and you know what their values are. So in here, the relationship between cause and effect is obvious to everybody. So when we have one of these problems, it's really simple to solve, and you can follow a well-known practice to exploit. This is really the exploit model when you're doing things. Now up here, in the complicated problems, you'd have known unknowns. So you know what you need to look at, but you don't know what values they have presently. All right, so this one says the relationship between cause and effect requires analysis or some other form of investigation and/or application of expert knowledge. So the key there is expert knowledge. So you need some expert to come along who knows the things to worry about, and then they go and they solve this problem for you. And notice down here in simple, we have the idea of what's a best practice. So that's kind of what I've been teaching you so far, best practices. So we know what the problems in software are, and we know how to address them. So for example, like testing. Software has bugs. How are we going to produce bug-free software? Well, we're going to write tests, and if we write them first, that's even better. Right? The next category is the complex. So the relationship between cause and effect can only be perceived in retrospect. So down here, we can make predictions on both of these, actually. But here, we kind of can't. We can only see the result after the fact. It says the emergent practice. Okay, so I'm going to call this the empirical process model over here. We'll come back to that. And then down here, we have novel practices where there's no relationship between cause and effect at a system level, and it's labeled the chaotic. So this is kind of like in emergency situations. Right, so there's some emergency going on. We have no idea what the cause and effect relationships are. All we can really do is act, sense, and respond. So note act is first, and then sense and respond. Whereas up here, we got this other word, probe, sense, and respond. Okay, so most software programming tasks are up here in the complex domain. So really, cause and effect in terms of working software, we only really see it in retrospect, like when we run our tests, right? Then we see if we succeeded in fixing the bug or not. And a lot of bugs are really hard to find. So they're definitely in this complex domain, but also the software that you make. Remember, we've got our 3 criteria for making our software, not just the verifiable, automated, and repeatable thing, but we have the right product, done right, and managed right. So the right product is the validation part, which we haven't addressed yet, so we're going to get to that if I'm quick. So a lot of times when you're building software, you don't know what the end product is going to be. And you might have a plan. If you're following the waterfall model, you think you have a plan for what the end product's going to be. But if we're following a more agile process, or something that acknowledges that we're working in the complex domain, so waterfall does not, it's over here in the complicated domain, we can respond to the changes that we see as we develop. So here we really have to kind of probe the problem, and then we're going to measure whatever the results of the probing is, and then respond. So if we're doing an agile delivery system or an agile deployment system, whichever one, we're going to start by, well, we'll say we start in respond, but really it's just to prime us to go into probe. We're going to push out a build. And then we're going to have instrumentation points in our build that tell us things about how our software is being used. So we're going to measure those things, and then we'll look at them. And we might notice that we had an assumption which is not being reflected in the way that our users are actually using the software. Or we can say, if we want to think of a traditional approach, we could probe to notice our customers have a need, and then we'll sense to figure out what is this exact need, and we'll respond by implementing a feature which fulfills that need. Okay? Then we push that build into the production environment. And then we're going to probe the way that our users are using our software, and we're going to sense some measurements. And then if we see, well, our users actually aren't using this new feature, we're going to have to figure out why. We can respond by either asking our users why, maybe they're not aware of the feature, or maybe they are aware of the feature and it doesn't solve their problem. Or maybe they've tried to use it and it was too difficult, so they abandoned it, etc. Right? So we can make a response to address any of those concerns. Then we push out another build. And then we're going to do our probe, sense, respond loop over and over again. So that's actually something called the empirical process control. And almost all software problems live up here, because when we start writing software, we don't know what it's going to be when it finishes. And I also mentioned I should want to compare and contrast that to the waterfall model. Give me a second to start a drawing tool. Oh, that's right. My CPU is being eaten alive. I do need to draw, though. Okay, here it comes. All right, so let me just make a new fancy drawing. Whatever, just do it. All right, so the idea when we're doing waterfall is we are here. That's us right now. We're there, and we're going to build a piece of software that's going to take us to our destination, which is here. And when we're doing waterfall, what we want to do is, remember, the goal of management in this mindset is to eliminate variation. So I'm going to change the color to be black, like that. Where is the brush width? Don't see it. It's not important though. So, oh, there it is, size. Shrink it. So what we're going to end up doing in waterfall is something like this. We're going to go from there to there, and we're going to follow this line to get there. Right, that seems right. right? That seems like the right thing to do. And that would be totally fine if we were down in the simple problem domain. So if we're down here, this is the way to do it. Like, there's no doubt about it. That's the way to do it. When you're in the complicated domain, you're going to do stuff slightly differently, but it's going to more or less look like that still. The problem is that most software is actually out here in the complex domain. So in the complex domain, we're going to do something a little bit different. Let me grab a green, and we'll make it actually green. There we go. So we're going to start off by following the same process. Okay, but then we're going to follow the empirical process model. So we're going to stop here. So this was our initial response, and then we're going to do a probe and a sense and respond. And we might notice, hey, there's actually something wrong with our original belief, so we're going to deviate slightly from the plan. Right, and then we'll continue along this way, and we'll keep developing these little work and then some improvements. Maybe we noticed here, oh, we've gone a little bit too far from where we should actually be. And then we can do another probe sense respond and another probe sense respond. And you notice we're deviating quite a bit. But then when we get to here, maybe the market shifts. And we've got to do something like that. So that would represent a significant amount of rework. And then we're going to go up. And then we're going to go up. And then finally, we've hit where we want to be, where the market actually is now. And I think the size was 40. And then we end up here instead. So if we had followed waterfall, we would have ended up there. So there's a difference between those two. So let's grab a blue. And it's not that big. The difference between them is that. Right, so that's the delta that exists between them. So if we follow waterfall, thinking we were in a simple problem, we end up here. But if we follow an empirical process model, we end up over here. Right, and this is an improvement, because this is where the market actually is, and that's where we thought it is. Right, or that's where we, hold on. Oh, that was a serious sneeze. But this is where the market ended up when we were finished, and we are much closer to it. Or maybe the market ended up somewhere over here and we missed slightly, but we're still a lot closer. Okay, so I'm going to pull up another reference for empirical process control to see if there's something like an image that's really good. Empirical process control. It's this probe, sense, respond cycle you keep going through. Let's look at it. And okay, well, how about in here? Empirical process. See if there's a nice picture. Nope. Nope. That is not what I want. Okay. So these are the important things, actually. Transparency, inspection, and adaptation. So in order to be able to probe, we need to be able to see things. Right, so we have to have something to probe. And then once we've done that probe, we get our data. We have to inspect it. This is the sense stage. And then our response is down here in adaptation. So we're going to have a process we build that has transparency baked into it, because we don't want an opaque process, because then there's nothing to respond to because we can't make measurements. We're going to inspect the results that we've produced so far. That's the sense stage. And then based on those results, we're going to adapt. We're going to make a change. Right, and when we do that, it allows us to follow something like this green line. Right, so there are deviations, and that does represent waste, because the idea would have been we went here directly to there, but we couldn't know that that's where we needed to end up to be, because there was actually this big change right here. There was no way to account for that change. I said that was an external change. These could have been internal changes, like our understanding of the problem we're solving evolved over time. to become better, right? But this was an external market change. There's no way to account for that. So with the empirical process control, you've got this thing you're making. You bake transparency into it so that you can make measurements. Then you make those measurements, and based on those measurements, you respond to them. So you change your plan. Okay. Okay. All right. So build projects around motivated individuals, give them the environment and support that they need, and trust them to get the job done. So motivation is important, but you'll notice it says build projects around those individuals. And then give them the environment and support that they need, and trust them to get the job done. So this is not how you would solve a simple problem. In a simple problem, you turn everybody into a cog with no care to their motivation, and the environment and support, that's all prescribed. And as a cog in the machine, their job is to do this particular thing and to optimize for it. So I would have exercises if we could do them, but we're not together, so we can't really do the exercise I'm thinking of right now. Okay, so the most efficient and effective method of conveying information and within the development team is face-to-face conversation. So again, this emphasis on person-to-person interactions over rigorous documentation and precise requirements. This one is my favorite. Working software is the primary measure of progress. So in other methodologies, especially ones that are very heavy on documentation, I'll just pick on waterfall some more. The first stage of waterfall is requirements gathering, ignoring the whole project charter kind of stuff. But the first real work is requirements. So the idea there is you produce a document that has listed in it hundreds and hundreds of functional requirements and non-functional requirements. And these are things that the software has to do. And you produce all of them up front. So hopefully from the drawing I did in the Paint tool, you see the problem with that already is, well, if you're doing all this up front, they're not going to be the greatest because understanding of the problem is going to change over time. What the customer wants, so understanding of a solution is going to change over time. And then there's always a risk that the market will change. And then your plan is going to be for the previous version of the market, not the current version. So back when we were doing waterfall, if you deliver your 100 requirements, that would be considered as progress to solving the problem. Okay? And I mean, it is. Having requirements is work, and having it is better than not having it. But you didn't actually deliver any customer value there. Like a list of requirements has very, very little value to the customer because they can't use it to solve their problem. Right? They could use it to hire somebody to make software, but that doesn't solve their problem immediately. So the work that's produced is not of value to the customer at all. The only real measure of value delivered to the customer is working software, because that's something that's actually going to solve their problem. I'm going to come back to that one. I'll leave it highlighted. So next guy, agile processes promote sustainable development. Sponsors, developers, and users should be able to maintain a constant pace indefinitely. So this is related to the overburden, which was Muri from the TPS, so the 3 M's, and also Mura for uneven flow. So constant pace, well, if your flow is uneven, then it's not a constant pace. And if you're overloaded, you can't maintain it indefinitely. So requirements are more like guidelines to help you to proceed. It depends on how we're talking about them. If we're talking about them in a waterfall model, no, requirements are hard, fast, like steel documents, steel cages, you could think of them as what the software must do. So it would say, so the way you could write a requirement would be something like, let's say that we're building a collision warning system for aircraft, and it will have radar. So it would be something like, upon receipt of a radar signal, the collision warning system will measure the distance to the object, and if it's within a certain range, the software will trigger an alarm. So that would be a requirement. And the alarm would be precisely specified as well. So they're not really guides. They are very detailed, precise statements of what the software has to do. We're not going to do those kinds of requirements, though. Right, continuous attention to technical excellence and good design enhances agility. Yeah, so this is reducing technical debt. We don't want to accumulate debt by making shortcuts as we go because we have to pay for them later. Simplicity, the art of maximizing the amount of work done, is essential. The best architectures, requirements, and designs emerge from self-organizing teams. So there is still this idea of emerging architectures, requirements, and design, but it's saying that they emerge from the team. They're not emerging from documents. Right, so in the waterfall model, we would specify the architecture up front. Right, the requirements would be specified even before the architectures, and then the design would be the third stage. So we'd have requirements, and then we'd have an architecture document, and then we'd have a detailed design document. Right, they'd all be specified up front, probably by the people who are not making the software, because the people who make the software are going to be code monkeys. Right, they're just given this giant document of the design and told to do it. So, those code monkeys are completely disempowered, which violates one of the other guides we saw up there. And then it says, at regular intervals, the team reflects on how to become more effective and tunes and adjusts its behavior accordingly. So this is more about the empirical process control. So not only are we using empiricism on the product we're producing, but we're applying the empirical process model to ourselves. Right, so we're going to have visibility on our productivity, so the number of feature points we produce per sprint. And then we can probe that and figure out, well, why were we slow this week, or how can we make this faster overall, right? That kind of stuff, and then we'll adjust our behaviors. Okay, so back to working software as a primary measure of progress. So I'm going to go back to the painting tool, and then we'll move on to the next topic. Okay, so I'm going to leave that guy there. So if we're developing software, I'll draw a little chart here. Where's my line? There he is. Okay, so we're going to have our x-axis, which is going to be time, and we're going to have our y-axis, which is going to be value delivered to customer. So time along the bottom, value delivered to the customer here. So if we're following a waterfall model, what's going to end up happening is we're going to have something like this. Right? It's going to be very flat at the bottom, and then all of a sudden it's going to deliver all the value at the end. Okay, but the problem is, or one of the problems is, I'm going to denote in yellow the concept of work. The work done, hey, click, there we go. Work done is going to follow something like this, assuming that there's no heroism at the end. All right, so that's the work that was put in, that's cost, but the value looked like this. So, here's where we do our requirements, here's where we do our architecture design, there is where we do our object design, this is all implementation and testing like this, and then finally we deliver to our customer. And then maybe after the first delivery we make a change and then they get all their value. Right, but there's huge risk involved in this. In particular, I can draw this line right here. Right, if anything happens to our project before this blue line, our customer got no value, but they paid all this cost. So this could be a market shift. This could be the project is canceled. This could be we ran out of money. Right, any of those things. Right, this could be regulations changed. Right, and then all of this stuff under this curve here is waste. All of that is wasted effort, because there was no value delivered. Now, if we compare this to a more agile model, which I'll have to then justify, we did some work up front that didn't really deliver much value, but then we started to deliver something that had value. Not a lot of value, but a little bit. And then we continue along this way, and we're developing incremental releases of our software, like so. Maybe we had a bad week here. And then we go up there, etc., etc. I could continue this line. let's say it goes like that. And then we get into a really strong trajectory where we're actually solving the majority of our customers' problems like that. So that's not a very flat curve, but you can see, I mean, if something happens to our project at the point of this blue line, what is wasted in this model? Well, it's going to be all of the junk in here. Oops. All of that would be waste. But that's way, way better than all of this being waste. And then we would have actually delivered this amount of value to our customer. So they actually have something for it. All right, so now I think I have to justify why do we get this curve and not one of these guys. All right, so I think that deserves writing on the slides. So we're going to go back here to our slides. So one of the things about most agile methods in software, and Scrum does as well, or it's true for Scrum as well, is that it is an iterative process where we're incrementally delivering value. It's iterative and incremental. So to use an empirical process, it has to be iterative. So we have to follow that probe, sense, respond cycle. And we're going to apply this over and over again. So the idea of an iteration is that we're going to apply our process model repeatedly over time. So we'll apply process over and over again. Waterfall is not iterative. Waterfall it's one process. You have your sub-process that's gathered the requirements. And once you're out of that, you go strictly into, we're going to specify architecture design, and then object design, and then implementation, and then testing, and then deployment, and then operations, and then maintenance, right? So that's the waterfall model. You don't iterate. It doesn't go back. It's not a loop. So maybe I should say that, in a loop. Okay, so in particular, we're going to run the, oh my gosh, empirical, that's definitely wrong. Process. Oh, did I spell it right? No. Empirical. So the empirical process. And that, again, is the, what was it? Probe, sense, respond. Okay, and we're going to apply that loop over and over and over again, continuously, more or less. So we'll do one loop, probe, sense, respond, and then we'll do another one and another one. That's the iterative nature. We're going to keep doing this same thing over and over again. So the next part of it is incremental. So this is super important. Okay, this says every iteration delivers an increment of the product. And then I'm going to put in brackets that has value. Now, when I'm saying value there, I mean business value to the customer. Nothing else matters. Okay, so every time we release something, it has some value to the customer. It may take a while until you can bootstrap to where that value is usable, and that's okay. It takes a while to get to a minimum viable product, which I'll define below. Right? But every time we release after that point, we add some value. So I'll draw a little picture of what that means. Do a shape here. Shapes. And then how am I doing for time? Okay, we're doing okay. Spend another 10 minutes on this. So let's say that our initial release, version 1, delivers that piece of the software right there. That's version 1. Okay, and then our next increment, we're going to, no, I don't want that to touch. Our next increment is going to produce something, okay, and it's going to include the piece we already built. So I'm going to paste it right here. I can grab it. Yeah, there we go. So the piece we already built, and then it's going to have another increment, which is going to attach to that. So it's going to be like that. Right, so every release, we're incrementing our product. We're adding something to the product incrementally. Okay, and then, well, oops, sorry. I want to grab this guy, and this guy. So the next increment, similarly, is going to add another piece of functionality. Oh, they don't line up. Oh well. Whoops. Like that. So we're building on top of what we've already delivered. Okay, it's not like we have a release that doesn't add value. So if you ever have a release that doesn't add value, that's a complete failure. Like if you ever have a sprint that failed to deliver value, that's a total failure. We always want to be producing some kind of value. There are different kinds of values, so they don't just have to be features. We could count refactoring. Refactoring is not going to deliver a lot of value to the customer, though. When we refactor code, we're rewriting the code without changing its behavior. So from that perspective, it adds no value to the customer. But it does have value looking forward to the future. We could say that, well, now it's going to be easier to add features. From this perspective, though, there's no value delivered to the customer. So it's not really an increment. Okay, we could also do bug fixes. Bug fixes definitely have value. They're not adding new features, but they are incremental in that we had this version of the software here that has a bug, and then our next increment is going to include some value that addresses that bug. So I'll move that guy over here. They line up there-ish, there, I think. Okay, so there is our next release, and then this little increment right there, that's going to include something that fixes a bug, and that definitely has value. So this is incremental development. We start off with something that has value, and then we add to it as we go through. And then the iterative thing, I should label this as iterative, is that we have this process that we're following, and we apply the same process over and over again. So that's iterative. Incremental means we release something that has value, and then we add on top of that something more that has value. So let's do an example of incremental delivery. Let's say we're trying to make a text editor. All right, so the first increment could be it just opens a window, it gives us a text field where we can type stuff. That's it. Nothing else. There is value there. I can now type stuff there. It's not very useful, but it is an increment. Okay, let's say the next increment is I can save what I typed. Like that adds a lot of value to a text editor. The next increment could be I can now open files. So it's not just it opens and it gives me a blank canvas and I have to type in it, but now I can open a text file and then edit that text file and then I can save it. Right? So that's a definite increment adding value. And then the next one could be it supports copy-paste, which we probably had to from the beginning, but whatever. And then maybe it will have a spell checker. That's an increment that adds value. And then we could do something that adds syntax highlighting. So that's an increment that adds value. And then maybe that only worked with a particular language. The next increment could add syntax highlighting for another language, like etc. So we started off with something that had some value, and then we added more functions to it incrementally. So this is what we're going for when we do all these agile methods. We're looking for an iterative solution where we apply the same process over and over that delivers software in increments. So contrast that back to this drawing here. This one down here. This is not incremental. Nothing was delivered during this period, and then all of a sudden, bang, here's all the software. Like there's no increments there whatsoever. Whereas down here on the green line, well, you can see I repeated drawing these green lines, so that's our iterative process. But every time I drew one of those green lines, it went up a little tiny bit, right? Sometimes it went up a lot. That delivered a lot of value. Sometimes it didn't, right? And actually, the fact that this is so uneven is concerning because one of the things we were looking for was even flow. So this sprint right here did not add a lot of value. Compare it to this sprint up here, that added a lot of value. Why are those two so different? That means uneven flow. So we should be looking at that and trying to fix it, whatever the difference was from here and here. And we would do that. So part of our iterations we saw on the manifesto, I believe. I think that's where it was. In the principles. Hold on. The team reflects on how to become more effective. So that's applying the empirical process model to themselves. Right, so at some point during our process, we're going to have a retrospective where we examine what we did, and then we're going to talk about why this increment right there was so bad. Probably right at the end of that increment. We're going to have to figure out why it was so bad, and now how can we eliminate that? Likewise up here, when we're doing so well, particularly this one, that's probably got the largest slope. At the end of this retrospective, or at the end of this sprint, we'd have a retrospective and we'd ask the question, why did we do so well on this particular sprint? And how can we keep doing that going ahead in the future? Right, maybe we had access to a resource here, so we would try to always have access to that resource. Or maybe we worked extra hours. That's a problem because that's not sustainable. And then that would represent overload, Murray, in our Toyota production system or in our lean model. And that would actually be something we try to eliminate. We'd say, well, we did so well because we worked extra hours, but that's not sustainable. So we should not be working extra hours. So even though we got a good short-term result, it probably had long-term consequences. Another thing could be, well, we didn't do any refactoring. We didn't refactor at all, and that is not technically a good practice. That's something we do not want to continue because we're going to pay for it later. Like it could be now that we're going to have much more sprints that look like this because we have to pay for that bad code we wrote in the past because we've accumulated technical debt. Okay. Anybody have questions? See if I can find a symbol for something that represent iteration while I wait for you to have questions. If you got a question, please type it. No. Okay, so I'm going to take no typing to mean no questions. Are you guys still there? Or have I put you all to sleep? Somebody type something. Hi. All right. You can go make dinner if you insist, because we already did attendance. All right. So this is my favorite topic. I could talk about software engineering forever, but I got to make sure I don't go down too many rabbit holes because we only have an hour and a half left. Okay. So let's start talking about Scrum particularly. Oh, I should go back. I mentioned XP, Extreme Programming. So Extreme Programming was a bundle of practices, but very fine detailed practices. So they are sort of guidelines about how you should write software, and it did prescribe a methodology as well. So if you're interested, go look at Extreme Programming, and there's a lot of good stuff in there. And some of the things in XP got taken to be industry-wide best practices, and some of the things got taken and absorbed into Scrum. Okay. But it's sort of, everything is building up off of what came before it. So let's take a look at Scrum. So Scrum is, that's not how you do it. Scrum is a framework. If you talk to Scrum people, they'll say it's not a methodology because you can do different methodologies inside of it. But I mean, it does prescribe quite a bit. So it's going to be a framework. And what it really defines is going to be 3 areas. So let me grab a reference. Okay. So with a lot of development methodologies, they were focused on the methodology itself. So waterfall defined, this is the process, here are the substages. Have something to do with Scrum. UI and UX, not really. UI is user interface, UX is user experience. We can put them in the Scrum framework, but they're not Scrum specific. All right, so where was I? Oh yeah, so early development methodologies just defined the methodology itself. They didn't really talk about how the internals of the methodology work. That kind of changed with the rational unified process. RUP actually said, here are some stages, which Waterfall already did. But then it also defined a lot of artifacts. So an artifact is something that's produced. So RUP defines a lot of artifacts. Scrum takes things a little bit further, and it defines a set of roles. It defines activities. It defines some artifacts. And then there are some rules. Okay, rules should be in quotes because whenever we have rules, they're fungible. They're soft. There are some rules that are much more important. So in terms of Scrum, it defines 3 roles. We have a product owner. So this is the person who represents the business interest on the product. So they represent the customer, basically. They're a stand-in for the customer and for other business interests. Okay, then we have the Scrum Master. The Scrum Master, hold on, I should probably write these down and not just say them. So business interests, like that. Okay, the Scrum Master is a facilitator. And sort of, we can think of them as a coach. They're there to help the team do Scrum properly. And then finally, we have the development team. So these are the actual developers that are going to make the software. It's not uncommon for a developer to be the Scrum Master. Okay. But the product owner and the Scrum Master should never be the same person because they actually have opposing views. Right? The product owner, he wants to extract as much value from the development team as he can. So if he's not very enlightened, he becomes an optimizer. I'm going to put that in question marks because they don't always become optimizer. Whereas the Scrum Master, the facilitator, and the coach, what they want to do is he's going to try to coach the team to delivering as much value as they can. So he says, well, that kind of sounds the same. Yeah, because I didn't express that very well. Okay, well, it's all about delivering value. Let's just change that. Sustainably. Right, so if they're ever the same person, well, your product owner wants to optimize, so they want to do an exploit methodology, and your team is going to have to adopt an explore methodology. Okay, so if we allow ourselves to fall into optimization, then that means we have either a simple or a complicated problem, but definitely not a complex one. Ugh, sorry, I was talking while I was typing. But we do know that we're in the complex problem domain, which requires exploration. Okay, so those two are opposed to each other. And then you have your development team itself, which is doing the work. So those are the roles. Now we have a whole set of activities defined by Scrum. First being the sprint. That's pretty important. Then we have sprint planning. Okay, then there is the daily Scrum. We'll look at what each of these do. There is the sprint execution. Well, sure. I don't remember if that's actually defined. Oops. Okay, so that's where the work happens. There's a sprint review. Okay, then there's a sprint retrospective. And then finally, there's this thing called the product backlog, which we haven't defined because we don't have artifacts yet. Backlog grooming. I don't know, the language around this step has changed a lot over time, so I don't know if that's the current word they use, but they all basically mean the same. All right, so next up we've got some artifacts. One big artifact is the product backlog itself. Okay. Then there's a sprint backlog. And then we have our increment. And I'm going to define that further. It's a potentially shippable product increment. Right, so if we're doing continuous delivery, we don't have to ship every increment we create. Because, a text editor that can't save or open files doesn't sound very useful. So we don't have to ship that. Oh, that's right. I said I'd define minimum viable product, and I didn't. Okay, we'll come back to that. There are a bunch of rules. There's too many to list, so I'll leave them out. I'll mention them where appropriate. So before I do that, I'm going to come back here and define what a minimum viable product is. Does anybody have a guess at what a good definition for a minimal viable product is? No guesses. Okay, I'm going to say it's a version, a version of the product where you could not remove any features and still deliver value. Okay, so if my text editor that a product with just enough features to satisfy early customers would provide feedback for future product development. Yeah, that's pretty good. So, but the question is, what is just enough? And then you got also the thing satisfy. All right, so I'm going to say that it's a version of the product where you could not remove any features and still deliver value. So my text editor, where you can type into a text canvas, but you can't save or open files or have syntax highlighting or select words or anything. I mean, it's arguable, does that deliver any value? Probably not, if we're thinking about what is a text editor. But it does deliver some value in that it gives me a little clipboard space where I could type stuff. But it's probably not minimum viable. Well, okay, well then let's look at the next iteration, the one that could open files. Could I take away the open file feature and have it still deliver value? That's the question you ask. So an MVP is the version of the product that you cannot remove any features from and still have it deliver some kind of value. Right, this is not like the minimal marketable product. That would be something else. That's where, it's the smallest version of the product that you would actually sell to people. This is just, does it deliver value? Okay. Right, so, well, if those are our things defined by Scrum, the roles, the activities, and the artifacts, then we've got to start looking at them. So I think we're going to start off with the activities, and we're going to see the artifacts as we go along, and then I'll just expand upon them as we go. So I got this little image here from scrum.org, I think. That's where it's from. Okay, so just throw that on another slide. Actually, since I have a URL, we'll do it that way. And I mean, it is some kind of drawing of the Scrum framework. It's lacking a lot of detail, but there's something there. We just insert this image. URL, where are you? There you are. Okay. All right. And again, this is from scrum.org, so I'll throw a little text box on there. Okay. All right. So we've got a couple loops in here. They're not explicitly shown to be loops, but this circle, that's a loop. And actually, this guy right there, that's also a loop. And you can see we've got this arrow going back here. That's a loop. So actually, so that circle, yeah, that's the daily development loop. Okay. And then that goes back as well, and the sprint review goes to the product backlog. Okay, great. Where to start? I think I want a more detailed picture. So I'm going to grab one from, can you zoom in? Yes, I will. But I'm going to find a better picture first. Where are we going? Documents? No, downloads. Downloads. Okay. It's my new favorite song, Thunder Thighs. Oh, it's entertaining. Okay. All right. So this is from a book called Essential Scrum. And that's the reference that I was using to the side here. And let's take a look at their model for Scrum. Oh, I gotta move. Okay, this is the one I want. Let's go to page 39. Okay, there's that guy. And then I want to make sure that I find the most detailed model of the process I can, because if it's lacking detail, it's going to be hard to expand upon. That's all agile junk. Okay, so on page 17, let's find this thing. Oh, I just lost my spot in the text. Page 17, long table of contents. Look at all those pages. It's crazy. Acknowledgements. 6. Oh, there was Sinfin, if you saw it fly by. Scrum framework. Okay, so that's what we just discussed. We've got these roles, activities, and artifacts, and also some rules, which we've left out. But this guy is what I am interested in right now. So let's zoom in. Actually, yeah, we'll zoom in. I'll just grab a snapshot and throw it on the slides, which is totally okay because this is for educational purposes. So why did you not make my little selection tool? Uh-oh. No, that's not it. That's settings. Okay, I have to type it apparently. Snapshot tool. Yoink. Okay, we're gonna grab an area. Okay. And the area we're gonna grab is this one right here. Okay. And then we'll throw it on the slide. It's a pretty good book. It's really hard to find a book that covers everything well. So, like, I've gathered all this stuff from 4 or 5 different books, but this one's got a pretty good high overview. Hey, where did it not copy to clipboard? Let me see what happened with it. No, it didn't. Okay, let's try to save it. Oh, there was a copy to clipboard button there. Well, that was smart of me. Okay, so it should be in pictures and a screenshot from right now. Yes. Can I? All right, so let's try to insert this guy. So insert image, upload from computer. And it's in, where is it? Hold on, let me find it. It's in pictures. This one. Yes, that one. Open. Okie doke, there we go. Stretch it out a little bit. And I'll have to cite where this is from. Okay, text box. This guy is from Essential Scrum. Okay. All right. Yep, this is pretty accurate. Let's start with the product backlog. So the product backlog is a list of features or other changes, but it's generally features that we want to add to our software. Okay, and they come from the product owner. That guy right there, that's the product owner. And he owns this product backlog thing. So a product backlog is a set of features, and they're typically defined in terms of user stories. So we'll come along and we'll say the product backlog. It's going to be a big list of user stories. And it is a prioritized list. It is owned by the product owner. Okay. So we should say, what is a user story? Well, I think we'll get a new slide for that because it's going to have quite a bit of stuff on it. So there's this thing called a user story. So this is different from a use case. Use cases are the old way of doing things, and I can teach you about those if you want, but they're pretty awful. User stories are much better. So user stories are these little stories that follow this form, or there's lots of ways you can write them, and Scrum does not prescribe this particular way, but it's just this is what people have adopted. So it would be something like as a, okay, so as a blank, oops, I don't want another bullet there. Hey, oh, I was holding the wrong key. As a blank, I want to blank. I think I have cap locks on. Do I? There's no indicator on my keyboard. We'll never know. I want to, so that. The lag is real. So that. As a blank, I want to blank, so that blank. Right, so that's the nuts of a user story. Now we can attach a whole bunch of stuff to user stories. So one of the things that we're going to attach, or rather our product owner is going to attach, is going to be a value. So this is really an estimated value. And it's up to the product owner and other business people to define that value, but that's their domain. So I'm just teaching you guys how to be developers. We don't need to worry about that at all. Right, that's the product owner's problem. But the product owner gets to define value. That's their job. Okay. Another thing that might be on a user story is our friend, the acceptance criteria. All right, so this is one of those high-level tests. And I mean, the user story tells us as a blank, I want to blank so that blank. But I mean, that's not really, it might not be clear what success looks like if that's the way we do it. So if we're talking acceptance criteria on a user story, we're going to follow the given. We've already seen this one. When. And then. Right, so this guy here, that is the given. And remember, that is the state of the machine / world. But it's mostly about the machine. When. This is going to be some event that occurs to trigger whatever is supposed to happen. And then the then is going to define the final state of the machine and the world. Okay, so return values, change in state, all that stuff. I'd consider return values to be a change in the state of the world. Okay, so we can have these acceptance criteria attached to our user stories to better define what it is, to sort of quantify what exactly success looks like. Because if you don't understand, if you can't express it in terms of a given when then, you don't understand the story. All right, one more thing that's going to be on here that's very important is a cost estimate. Like that. And you know what? I'm going to come down here. And the estimated value, that is a responsibility of the product owner. Like this. And then the cost estimate is the responsibility of the developers. All right, so the product owner is not allowed to influence the cost estimate, and the developers aren't supposed to implement the estimated value. I say not allowed, but I mean, you can. Like a product owner might say, well, this feature is pretty much the same as what you did last week. Why is the cost estimate so much higher? All right, so that's influence. But the ultimate say in a cost estimate resides with the developers, and the ultimate say of the value delivered by a feature resides with the product owner. Right, that's their responsibilities. All right. And these kinds of things, the user story and the acceptance criteria, and to a lesser extent, the estimated value and the estimated cost are developed as a team. So you work together to develop these things. Because you might get a user story that comes in that's completely ambiguous. Like it might not be understandable because it's written in domain-specific jargon, or you cannot determine what the acceptance criteria would be based on that story. So it needs to be developed as a team. So the product owner will be there representing the business interests, and then your developers will be there to make sure that the user story, like they understand the story, and that the acceptance criteria makes sense and the story makes sense, because if they don't understand it, they definitely cannot develop it. And the Scrum Master is there to make sure that they follow the Scrum framework. Right. So let's talk about then. So one of these events is the grooming of the backlog. This thing right here. That's one of the activities. So product backlog grooming, they have it here at the start of a sprint, but really this thing is kind of outside of the sprint because there's a lot of debate about when this should occur and how often it should occur. This is one of the least defined parts of Scrum, where this guy is, what it is, etc. So the idea of grooming the product backlog is over time things will change, and they don't even have to change. So it could be that we've got a bunch of user stories that aren't developed enough, and they need to be developed a bit better. So developing user stories and acceptance criteria. Okay, stuff like that. Developing them, reprioritizing. That's really the product owner's job. But this is one of his tasks, and we're talking about the activity now. Reprioritizer? No. Reprioritizing items. Maybe assigning estimates. Estimates of cost, estimates of value, stuff like that. And really, the product owner is going to do a lot of the grooming by himself, but to get things like estimates and to make sure that the acceptance criteria and the user stories make sense, he has to consult with the developers. So there will be this event where the product owner and the developers get together to groom the backlog. And the product owner, that's basically the product owner's meeting. So he will say, well, we've got these user stories. They need to be a little bit more developed. Can you guys give me feedback on it to make them make sense and to make sure the acceptance criteria makes sense? And I mean, it's not the developer's job to do that work in that they're not supposed to write the user stories and the acceptance criteria, but your product owner is not going to be able to do it completely independently either, because he needs to get feedback from the developers. Does this user story make sense? Does this acceptance criteria make sense? What changes should be made to it? That kind of stuff. And if the developers say, we don't understand this, then it might be the product owner's job to then rewrite that user story, or the product owner might have to go and talk to the customer and say, we have this story we're working on and we're having problems quantifying what success looks like for it, and they'll talk to the customer to resolve that ambiguity. Stuff like that. Okay. So because you guys are developers, we're going to talk about the cost estimating. So this is where we would have done another activity, but we don't have enough face-to-face time to do it. All right, so we're going to talk about user story cost estimates. Then I think I'll do an example of a user story. So what you normally do when you're estimating costs is everybody talks about the user story to make sure it's clear. If you have acceptance criteria, everybody talks about the acceptance criteria to make sure it's clear, and everybody is on the same page as what you're talking about, or on the same page about what you're talking about. Right, and then you would ask for a cost estimate. So, as I said earlier, at least I hope I did, those cost estimates are the responsibility of the developers. And the ultimate say in cost estimates lies with developers, because they're the ones who are going to do the work. And so they are the experts on estimating the cost. Your product owner is not going to be estimating costs, because if you do, they're going to underestimate everything, right? Because they have an opposing view from the developers. They're trying to exploit the system as well as much as they can. So they're going to have lower estimates than necessary, or they might not be aware of complexities involved, right? So your developers are the experts on knowing how to implement things, so the responsibility for providing an estimate lies with them. Okay. So by developers primarily. Likewise, for the Scrum Master, the Scrum Master might be more experienced, but it's not his role to provide estimates because he's not doing the work. So that's very important. By developers who are going to do the work. And we'll see why that's important once I suggest one way of making your estimates. So one way to make the estimates is after everybody's talked about this user story, and maybe I should give an example before we do that. I don't think I need to do an example of given, when, then, because we've done a couple already. But here's an example. Okay, so as a what are we going to call themselves? Cellular phone client, customer, owner, I don't know, cellular phone user. Oh, that's not it. As a cellular phone user, I want, and actually the to is not a necessarily part of the framework, but I want to set up automated payment. Automated payment, just automated payment, that's detailed enough. So that my bill gets automatically paid, so I don't have to think about it. Or so I don't have to think about it, and I don't miss a payment. Miss a payment, and then there's another so I'm going to tack on here. So I continue to receive service. So that's kind of a long so it's not a great one. But really, I mean, so my bills get automatically paid, so I don't have to think about it, and I don't miss a payment, so I continue to receive my cell service. All right, so that's a user story. As a cell phone user, I want to set up automatic payments so that my bills are automatically paid, so I don't have to think about it and don't miss a payment, so I continue to receive service. So there's a user story. Kind of like that. And then we could define what the acceptance criteria would be. You know, given the customer has a credit card, when they enter their credit card details for automatic payment, then their future bills will be stored by will be paid by charging that credit card. So that could have been the acceptance criteria. Right, and then our product owner will have assigned some kind of business value to that. And it's totally up to them how they do that. Usually it's a numerical value anywhere, well, it depends. Okay. Now back down here at cost estimates, how are we going to determine our cost estimates? Well, our developers are going to make up a cost estimate. There's going to be a group of developers, typically. So there's a lot of recommendations. I'm gonna write down a few of them. So the units are arbitrary. So it doesn't matter what unit of cost we adopt. It is completely arbitrary. Okay, and normally what happens is we define the estimates of cost relative to previous estimates. So every estimating framework is going to be specific to each team. I mean, you might try to initially start off with them being hours, but you'll find that our arbitrary units are arbitrary. Like they might have been initially hours when we started doing agile methods, but then we got better. So now each one of those things that used to be an hour is now 20 minutes. But we continue with the value as if we were using our original scale, if that makes sense. Not unit. It's arbitrary. So one recommendation you'll find is that you have predefined steps for your cost estimates. And the most common is going to be the Fibonacci sequence. Oh my god. There's no chance of me spelling that right. Fibonacci? Let's put that in there. Fibonacci. So let's pull up the Fibonacci sequence. And then I'll explain to you why we would use fib. So slow. All my bandwidth is being eaten. Okay, come on. Here we go. So a Fibonacci number is the sum of the two previous numbers. So we're going to start off with 0 and 1 as our initial state, and then the next number is the sum of those numbers. So 0 plus 1, it's still 1. Then the next number is the sum of the previous, so 1 plus 1 is 2. And then the next one is the sum of 1 and 2, so it's 3, and then 2 and 3 is 5, 8, 13, 21, etc. So I'm going to grab, that is not numbers, are you serious? That's an image? Oh my gosh. All right, so I'll type some of them out. So Fibonacci, we're never going to have a 0. So let's just start with a 1. And then I'm going to ignore the second one. We're going to have a 2, and then a 3, and then 5, and then 8. And then 8 plus 5 is 13. And then 13 plus 8 is 21. And then 21 plus 13 is 34. Oh, I really hope I'm doing this right. And then we've got 55, and then we've got 89, etc. All right, so the idea of adopting Fibonacci is that we've got this base unit of 1. This guy is about twice as difficult as that one. All right, now this one, the next step, it's like 3 times as difficult as the original, but it's just the sum of both of these. And then there's no 4. We go straight to 5. So the idea of saying we're going to follow the Fibonacci sequence is you don't get into stupid arguments like, is it 28? Right? It's either 21 or 34. All right, so we're not going to worry, is it 24.5? No, if it's 24.5, then it's 21. So stuff like that. So we don't get into like hair splitting. And it's kind of like, the other way to do it is what's called t-shirt sizing, which I don't really like because how do you, is 3 smalls a large? I don't know. T-shirt sizing, where you have things like small, medium, and large. And I think actually it's very similar to Fibonacci. So we could say that a small is representing 1 unit, a medium is going to represent 2 units, and a large might be something, well, let's actually change that up. Let's say that one's 3. And then this guy here is something like 8. 8 units. And these are arbitrary. Okay. So we're going to have these steps. Okay, then the process that we're going to go through is we have this initial discussion about the user story, and the acceptance criteria. And then we hold something that's kind of like a vote, but it's not exactly a vote. It's more of a poll. So independently, each developer will write down, or will write their cost estimate. And a lot of groups will actually have pre-defined index cards with, for example, the Fibonacci sequence on them. So a 1, a 2, a 3, a 5, an 8, a 13, a 21, a 34, and a 55, 89, etc. And then there's the reveal. So everyone reveals their estimates. Okay, if they're roughly the same, then you finish the process. So I'll come back to what it is to finish the process. If roughly the same, exit. We're going to exit our poll. If there's big differences, and if we're doing Fibonacci, there could very well be big differences, then what you do is you have the lowest estimate and the highest estimate have a little mini discussion where everyone hears what they say. Have a little discussion, right? The highest estimate and the lowest estimate discuss publicly. Other people are allowed to say things, but the main intent of this discussion is it's between the low estimate and the high estimate. So you're not allowed to gang up on anybody. Right? It's a respectful discussion where people get to state their views, and maybe they state something that the rest of the group hasn't thought of, or maybe they had an uncertainty, so they left a giant margin of error that someone in the group can address that would, cause them to change their estimate. Okay, so they're going to discuss it publicly, and there's no ganging up on people. It's primarily about the lowest and the highest discussing. But I mean, if somebody does have an answer to a question, they're more than welcome to put it in there. Okay, then they repeat the process. So we're going to everybody independently vote. Some people will change their estimates based on the discussion. They're going to reveal their answer. If there's still differences, you can go through this process again. Eventually, though, you're going to have to stop. Okay, so even if there are huge differences remaining, you have to stop eventually. Okay, so what do you do if there's still a big difference when you stop? Because normally this little discussion thing will happen 2, maybe 3 times, but no more than that. Okay, so I'm going to say repeat 2 or 3 times. Two or three times. Actually, and you know what? I think that guy can go up here. All right, so let's say that we've gone through this process, I don't know, twice, and we've ended up with something that looks like this. Our estimates are, we've got a 5, we've got an 8, we've got a 5, and a 13, and a 34. So even after all these discussions, somebody is still an outlier saying 34. We've had our discussions, we've done it 3 times. This is where it lies. So what should we do about this? Does anybody have any ideas? What do you make the final estimate? Okay, so one suggestion is, do you take an average? Right, and that's understandable. That's where a lot of people go at first. So maybe we decide on 13 because it's kind of in the middle. Maybe we decide on 21 because it's closer to an average. I haven't done the math, I don't know. But an average is one choice. So the recommended practice is that you take the high estimate. Okay, there's a couple reasons for why you take the high estimate. One, if you take an average, then it encourages the people who are down here to strategically vote, right? If this guy's saying it's 34 and we think it's 5 and we know we're going to take the average, then we're going to vote 1 to bring it down, right? So problems with taking the average, it really is going to enable strategic voting. And that's something we don't want. Because then you've got like a game within the game, and that's just not good, because it generates a lot of animosity. Okay. Another reason why we take the high estimate is that everybody, if you take the high estimate, it's ensured that everybody was listened to. Okay. So if you're discussing a feature and most of the group is down in this 5, 8, 13 range, and somebody said 34, if you don't take 34, then you've basically said that that person's opinion does not matter. And that is not good, because we're talking about professional people with professional skills. And you never want to tell someone that their opinion doesn't matter, even if we're not professionals. Right? Because if you tell somebody their opinion doesn't matter, then they are checked out for the rest of the meeting. Like, they're not going to participate. Right? And if this is something that happens more than once, then they might not even participate from the beginning of the meetings going forward. So that's another reason we want to take the high estimate. The final one, from the managerial standpoint, is that if I take 34, then everyone on the team is willing to implement that feature. I'll go back to why we're using fibs. So this is the most important one. So if our initial estimates were 5, 8, 5, 13, and we took the average, it's definitely less than 34. So whoever bid 34 is not going to want to do that feature. They're not going to be willing to do that feature. It says, no, you think it's going to be a 5, then you implement it. It'll be that kind of thing, right? Because I think it's 34. I'm not touching it. But if we come out with an estimate of 34, then everybody on the team is willing to do it, even the guy who says 34. And in fact, these people who bid 5s, they're going to be just itching to take it. And that means Mr. 34 is not going to have to deal with it. Because if these people think it's super easy, but it's got this high weight, then they're going to want to grab it. But even if these people are not available or not able to do it because they're on something else, Mr. 34 is willing to take it, because we said it's a 34 difficulty, and that's what his estimate was. Does it impact cost? Well, we're talking about real cost and estimated cost. So these are all estimates. If it turns out that it was actually a 5, then that's fine. But it's going to look like for this sprint, we pushed out a feature that was worth 34. So it's going to look like a good sprint. And then when we do our retrospective, when we ask, well, why did we do so well? It's because, well, this thing that was 34 was actually an 8, not a 34. And how could we solve that? Well, there will be a reason that this person thought it was a 34. So you can look into that. Or it turns out that they were right. Like maybe this person wasn't aware of a certain library, or they were lacking a certain skill. So to them, it would have been a 34. So how do we address that? Well, we can improve training for this person, or whatever. So why do we use the Fibonacci numbers? It's to avoid hair splitting. Like say we're looking at something that's between a 13 and a 21. I don't want to get into a debate. Is it an 18 or a 19? That's close enough to 21 to just say 21. Right, so if you allow the entire number range, somebody could come in with 24.5, and then there's a discussion, is it a 24.5 or is it a 25.6? Like that discussion is not worth anything. If it's any of those, you just say it's 21. Right, so we don't worry about the fine details of our estimates. These are just kind of coarse estimates. As we get bigger, the numbers get further and further apart. So up here, what is it, 144? Right, it's just big. It's a big feature. What's the difference between 89 and 144? Well, it's 55, which in and of itself is a pretty big feature. But I don't want to get in this scenario where I'm debating, is it 112 or 120? Right? It's either an 89 or a 144. And then if we're having our discussion, if everybody's saying 89 or 144, we take the high. And we know it's not too far from what it'll really be because those were the two numbers we were looking at. Does that answer the question about why we use fib? Okay, good. Good question. Thank you. So we do this sort of polling thing where everybody writes down their estimate and then they reveal. If they're roughly the same, you just take the high estimate. If there's big differences, then the lowest and the highest will have a little discussion publicly so that everybody hears about it. You're not allowed to gang up on the person. And then you keep doing this process until it seems like you have a resolution or it's not going to resolve, because eventually you get to the point where we just need to move on, and then you take the high estimate. The reason you take the high estimate is because, well, if you took an average, then people would start voting strategically, which is not good, because we want their estimates to be true estimates. Another reason is if we take the high estimate, then we're certain that everybody was listened to. The person with the outlying estimate, they got to voice their opinion, and they're going to continue to participate because of that. Right? And then finally, everybody on the team is going to be able to implement this feature, because these people who bid 5, well, they're going to definitely want to do this thing that's worth 34 because they think it's easy. They'll be all over it. And even if none of those people are available, the person who said, I think that's a 34, they'll be willing to work on it because its value or its estimate was 34. So that is all backlog grooming. So I need to move forward. So the next thing that's here is sprint planning. Basically, all sprint planning is we're going to take items from the backlog and we're going to put them into our iteration plan. So we're going to address those things on the backlog in this iteration. And it's important, we're going to complete them. So everything that we take from the backlog into the sprint backlog, I'll write this down. So we've got the sprint plan and the sprint backlog. Right, so what happens here is we're going to take the top elements. Well, it's done in concert with the product owner. So we're going to take elements from the product backlog. And this is going to be heavily influenced by what the product owner says. It's basically their choice. The only thing the dev team can do at this point is do something like say that story is not sufficiently developed, or the story has changed since we made our estimates, and we don't think that estimate reflects the story anymore. Like that kind of thing. But taking elements from the product backlogs mostly up to the product owner. Okay, now we got this question: how many? How many elements do you take from the backlog? So this is going to be based on project velocity. So it's based on velocity. Okay. So velocity is going to be a historical measure. So velocity is basically how many cost units are delivered per sprint. So our developers are making all these cost estimates, and then they're going to do a sprint. So they're going to take as much work as they think they can do. And then at the end of the sprint, they're going to measure what was actually delivered. Okay, and hopefully it's everything they took, but I mean, accidents happen. And then the things that were delivered, well, they all had cost estimates on them. So you add up the cost estimates, and that is your velocity. So it's the sum of the cost estimates. And as you've done this over time, it's going to stabilize to say, well, on average, we're delivering this many cost points, whatever they may be. So that means our next sprint, we expect to be able to deliver that many cost points. Right? And then as you're doing your retrospectives, that figure will start to normalize. It'll start to be consistent. And if it's not consistent, then you've got to address why, because variation is one of the forms of waste in our lean process. So you'd use your empirical process to determine why is there all this variation and try to address it. So you have your idea of product velocity, and it's the sum of the cost estimates of what has been delivered over time. And that will basically define how many backlog items you take. So you'll take a number of backlog items approximately equal to your velocity. Okay, so the backlog items. So we're going to take the sum of their estimated costs should equal the velocity, approximately. Right, and the product owner is going to get to choose what things you work on, unless there's a technical problem with something. Because what they're going to do is they're going to look at their estimated values, and they're going to look at your estimated costs. And remember, they're an optimizer, so they're going to give you the user stories that deliver the most value for the least cost. So that is one of the really good side effects of this. Okay, actually, I'm going to say it's more than heavily influenced. This is kind of directed by them. So what they're going to want to do is they're going to optimize. And they're going to take the user stories with highest value over cost. So the side effect is will be always working on the most important work that you can be doing. Right? You're never working on a feature that doesn't matter because your product owner would have not given you that feature. Like if he's got a choice between something he estimates to be 350 and 200 and your cost estimate is the same, he's given you the 350. Right? Likewise, if he's got something that is a value of 300, let's say he has 100, 200, and 300, and your cost estimates are, let's say, I don't know, 5, 5, and no, that doesn't work because they add up to the same. Let's say 200, 200, and 300 are his estimates of value. The two 200s you've estimated as being cost 1, but the 300 you estimated as cost 2, well, he's going to give you then the two 200s because he's going to get 400 units of value out of 2 units of work, whereas with the other one, he would only get 300 units of value out of 2 units of work, right? So you're always the most productive you could be from the business perspective, right? And when you're eliminating variation, that becomes predictable, and that's super important. Does anybody have questions about that? I'm not sure if I really described that well, because I said a lot of things without writing them down. So questions about the sprint plan and the product or the sprint backlog? I'll fill this in. User stories with the highest value over cost, always doing most important work possible. It's not the most important, always most productive. Okay, so I'm going to take no questions, no typing to mean there's no questions. If you guys have questions, please just type them. All right, so there's another side effect. Now that we have this velocity, we can learn all kinds of interesting things. Okay, so I'm going to call this transparency. So everything is completely visible when we're doing all of this. So the backlog is always visible. Okay, the work in progress. Oh, I should probably fill this in. No, that's when we're actually doing the sprint. I'll leave that till we get to that point. Backlog is always visible. Velocity, always visible. Okay, delivery of value, always visible. Everything is always visible, with one exception. We're not there yet. So if I've got all of this stuff transparent and I can estimate velocity, so let's go back to our drawing tool to demonstrate this. And I'm going to need a new document. Okay, so let's say that I am a product manager or a project manager, whoever's in charge. Or sometimes that's the product owner. They'll do that dual role. Okay, so here's my axis of value over time. So we got value on the vertical and we got time on the horizontal. Okay, and then what we're going to do is, as we're developing, we're going to have a sort of, this is going to develop. We'll have our first line of value delivered go like that, and then another one 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 like that. Okay, now we can do some statistical analysis on this line. So I notice that if I do this, I'm touching the line on both sides. And if I do this, I have this estimate here. All right, so that's a rough estimate of our progress looking forward. Okay. So now I can start to ask questions. So if I am a product or a project manager or a product manager, I can ask the question, what will we have done in the software on a particular date? And there we go. So we just draw this line up, and then I'll just put a little label under it. It's going to be, I'll make it a darker yellow. Do this one right there. Why am I not typing? Do I have to just start typing? No. Why are you not typing? Type. Oh, thank you. Well, okay. I've never used this tool to write text before, so let's try that again. Whatever. Okay, forget the text. Let me get rid of this, because this is not working out. So the question might be, what are we going to have done on this date? Well, here's our low estimate for the features that are done, and there's our high estimate. Okay. Another question might be, when are we going to be able to release? So release might be some minimum number of features, right? So when can we release? Well, okay, there is the low estimate of when we can release this version, and there is the high estimate of when we can release this version. So sometime between those two dates. Right, so velocity is extremely valuable to managers because they can make predictions around that kind of stuff. That's another reason why it's important that it be consistent. There should not be variation. Okay. Okay, so that's that. Okay, so what can we do with this? All right, so from there, oh, it's getting slower and slower. Can estimate features ready on a certain date. Both high and low. And we could also estimate a date when certain features are ready. Okay. So let's go back and plow through this thing. I've only got 20 minutes left. Okay, so here's your sprint execution. This is when you're doing the actual work. And I'm just going to leave a couple of notes about that. I mean, one big point is follow test-driven development. Okay, so sprint execution. You want to follow test-driven development. You want to do all the practices that we've been doing up to this point. So testing, source code control, and object-oriented stuff, all those things. So do the work. So we're going to use TDD. We're going to have a revision control system, whatever it may be. We're going to use objects. We're going to use promises, right? All these things we've been learning as we went. Okay. So when you're in the execution, what we're going to have is sort of a chart of all the features. It's going to be a table, actually. A table of all the things that are in our sprint plan. So I'm going to insert them like this. Okay, what do I need? Okay. So it's going to be like this. We're going to have a whole bunch of things that are to do. We're going to have stuff that's work in progress. We might end up with stuff that's blocked. And then we're going to have done. So I'm not going to write down what these all are, but this could be like user story number 1 is a to-do, and then maybe user story number 2 is, user story number 2 is a work in progress, and then let's say that user story 3 is done, and then let's say user story 4 is blocked. Okay. So you're just going to have this board, and you're going to be moving things from the left to the right, or, modulo this weird blocked status. Ideally, this wouldn't exist, but the reality is that it exists. Okay, and that's really all there is to sprint execution. I should mention that all of these user stories, once they're in this system, they belong to the team. Right? They don't really belong to individuals. An individual might take one and work on it, but they might get to a point where they need to hand it off to someone else. So an example for that would be if you've got an object that needs to persist in a database, you might have to give it to a database person. The database person will be on your team, though. Right, so all of this work belongs to the team. Okay, and the goal is at the end of the sprint, everything is in the done column. Right? You don't want anything left in work in progress. So if you're not disciplined, you'll end up with a whole bunch of stuff in work in progress. But remember, our only measure of success is working software. Anything that's in work in progress is not working software, counts for 0. So if all of your stuff is in work in progress at the end of sprint, then you delivered 0 value. So that is a complete failure. So if we talk about work in progress from a production standpoint, what this represents is, I haven't looked. If anybody knows, post it. What it represents is inventory of unfinished work. And inventory, generally speaking, is bad. So inventory represents capital that's been tied up and it's not producing any value. So I said anything in work in progress does not deliver value, but it does represent work that's been done. Okay, so the work that's been done, well, there's a cost for that, and it hasn't delivered value. So you've paid for something, and it's not worth anything. So that's bad. The other big problem with inventory, work in progress, is that things change over time. And the longer they stay in here, the more out of date they'll become. So there's a risk of a necessary change. So we could start working on something. If we don't deliver it, then there's a risk that things will change. And then all this work will be useless and it has to be discarded. Okay, let's go back to our diagram to make sure we're making progress. All right, next is the daily Scrum. So you can see here it's got inspect, adapt. So this is part of our empirical process, just like we're going to have more of it out here. But right here, everybody gets together once a day, or whatever is prescribed. Typically, it's once a day in the morning, like one of the first things, but not necessarily the first thing. Daily Scrum. And what you do in the daily Scrum is there's a bunch of ways you can read references for it, but one of the things that I would put in here is what you did yesterday. Okay. What you're doing today. and anything that is blocking you, if it eventually catches up. Okay, and the reason you do this sort of on a daily basis is so that everybody on the team knows what's going on at all times, because the more visibility we have, the better. And if you're saying, what you did yesterday, that might prevent someone from duplicating your effort. If you say what you're doing today, they might be able to say, oh yeah, I did something like that. Check out this library or go talk to this person because they know all about that. And the same thing for saying what's blocking you. So if you say this is going to block me or this is blocking me, somebody might have a solution for that. And if no one can come up with a solution, then they can come up with some kind of plan to address it. And your Scrum Master will be there to direct it. So make sure that you're following this kind of format. And these things, so the whole meeting is typically 15 minutes-ish. And they usually call it a stand-up meeting. Nobody sits down, everybody's standing. So there is no tendency to, be comfortable. You just stand there, you say your thing, nobody goes on for too long because nobody wants to stand there for too long. So ideally, 1 to 2 minutes each, and about 15 to 20 minutes total. If it's going longer than that, then you need to be more brief. Okay, actually, let me go back here now that I've said that. I missed something. We didn't say anything about the size of a team. So Scrum actually does provide a number. And I can never remember that number. I always look it up right before I take the test. Wait, no, it was Dunbar's number. No, it wasn't Dunbar's number. It's 5 to 9. That's it, because it was 7 plus or minus 2. Okay, so 7 plus minus 2, which is 5 to 9, like that. But the other way to remember it that's better than this is 2 pizzas. Your team is 2 pizzas large, so you should be able to feed the team with 2 pizzas. Large pizzas or extra large pizzas. All right, so if we've got 5 to 9 people who are talking for 1 to 2 minutes, well, that's 15 to 20 minutes. And actually, if we're down to just 5, it can be much shorter. So maybe we'll make that 10. Okay, so who's in attendance? The entire Tev team. The Scrum Master is in attendance. And optionally, the product owner. Usually, they don't come to these, though. There's no hard rule that says they can't be there. I'll put that in there, usually not. Because this is really a development activity. What you did yesterday, what you're doing today, what's blocking you. The product owner, the blocking part might be relevant to them if it's a business question. But really that would be it. Because ideally your sprints are short enough that they don't need to monitor you closely enough to know what's day to day. If you're on a 2-week iteration, that should be enough feedback from a business perspective. Oh, that's right, it was above. Okay, moving along. Next, we have our potentially shippable increment. Good. So at the end of your Scrum, all the stuff that is now in the done column is your increment, like that. Potentially shippable increment. All right, this gets into something that needs to be discussed, the definition of done. What does it mean for something to be done? Like, it could mean different things to different people. So fortunately for you guys, it's defined by the team. Not just the dev team, the whole team gets to define what done means. So the idea is the team will come together, they'll come up with a common definition of what something means to be done. And then when anybody on the team says done, that's what they mean. So for example, a definition of done could be, so I'll put a little thing there. Actually, I'll say could be. Could mean. Written, actually not going to say written, we'll say implemented. Implemented, tested, all tests pass, documented. It might include refactored or not, so I'll leave that one out. Checked in, and merged to master. All right, that's one definition of done. All right, and then your team can change that however they see fit, and they do that during the retrospective, which we haven't gotten to yet. But there's no saying, oh, it's done except for there's a test that doesn't pass, or it's all done except it's not checked in, right? That's not done. The team decides what done means, and then everybody uses the same definition of done. Okay, so that's what it means to be done. Maybe that should be back in the execution part, but it fits here too. And remember, these are potentially shippable increments, so this stuff is ready for delivery. Or let's not say ready for, let's say suitable for. To production. So the production environment. The customer can use it. So it's suitable for delivery to production, and it adds, this is the increment, business value. So whatever is in this increment contains some kind of value, and if we can add it to the existing product. I mean, everything is an add that we've done. So we can always look at a changed software to be the addition of a delta. So it's addition of a change set. That's the addition, right? And we did that delta for some reason, ultimately to add business value to the customer. So it's going to add some value to the customer, and it's suitable for delivery to production. So that's our shippable increment. Okay, now once we've got that guy, the next thing is a sprint review. And you'll notice it's got inspect adapt written on it as well. So this is part of our empirical process control. So the sprint review. So this is at the end of a sprint. So this is the empirical process. So we've got our probe, sense, and adapt going on here. And basically what it is the dev team with the Scrum Masters overseeing is going to present the increment to the, well, to, we'll say who, the product owner, definitely. The product owner has to be there. And potentially other stakeholders. So all those people that the product owner represents, they might be there as well. Okay, so that's the sprint review. This is what we made, this is what it does, and then the product owner will go on about, you know, what value this gives to the customers, and the other stakeholders will nod in agreement, or they'll yell and scream because it's not what they wanted. That's all fine. And that's basically how it goes. They make the decision, do we release this or not? Or even if you're doing continuous delivery, you still have this review. This is the stuff we made. This is the value it delivered. You know, these were, well, you're not there yet. We were just talking about business value. Okay, so this is the outside looking in to the team. They're checking your progress. They're seeing what you made. And then you do other stuff like you update your velocity. You update your burn down charts, which we haven't defined. But it's just another part of visibility. You can look it up. It's very similar to this chart here, except it goes down like this. but it's basically the same chart. It's like this is like how many features are left to implement, and then this is time, and then instead of this guy going like that, he comes down like that. But it's the same chart, just rotated. Velocity, burn down charts, product estimates, not your feature cost estimates, but like those like questions I asked about when will we have this feature, or on this date, what will be included, like those kinds of things. And that's all the product owner's responsibility. But he gets this information from the sprint review. Okay. Last but not least, we have the sprint retrospective. Sprint retrospective. Yep. All right, so the sprint retrospective is also one of these empirical process control things. So we've got our probe, we've got our sense, and we've got our adapt. Okay, so for a sprint retrospective, typical format is something like this. What went well, that's where you get to talk about your successes. Okay, I'll fix that later. And hold on. What went well, I'll fix it now, I lied. Hey. What went well, what didn't go well, and most importantly, what would you do differently? So what went well could be, the database part of the automated payment system went really well. What didn't go well? The interface to our credit card processor, that was a pain in the butt. And what would we do differently? We'd probably do a little more research on that credit card API before we implement it next time, and we might even make a spike solution. So a spike solution is like a little miniature prototype for a feature. It's an exploratory tool to discover that you understand how the APIs and stuff work together. It's not intended to make it to production, it's just for you to experiment and to learn. So that would be an idea of what you would do differently. Right? And it could even be, well, we didn't have access to this resource that we really needed. And what would we do differently? We would plan for that better and try to figure out who to contact about that. Or it could be as simple as we'd have it always available, which might not be realistic. Right? So the real one would be we'd figure out a way to get that resource when we need it. So stuff like that. So that's a sprint retrospective. Who's there? Okay. You got your Scrum Master. They're there to make sure that this happens and that everybody plays by the rules. The dev team is there. Okay, and then who's not there? Product owner. Okay, you don't want your product owner at this meeting because you want this to be an honest discussion of what went well, what didn't go well, and what would be done differently. And this is really the nuts and bolts, the nitty-gritty details of the process. And this is the product owner is not they're not supposed to be a technical development person. They are representing the business side, right? So, I mean, if we have an argument in here, which happens in a retrospective, about why something didn't go well and, oh, you should have did this instead of that, that's not something you want your product owner to see for a lot of reasons, because they're going to lose confidence in the team. They're going to stick their nose in it when they really have no say on it because it's a development issue, not a business issue. The team might decide, oh, well, we had this user story that was not developed well enough because we couldn't implement it, we didn't understand it, or whatever. And then what would we do differently? Well, we'd make sure that we don't allow something into the sprint backlog that we don't understand, right? That could be the what we do differently part, right? But you don't want the product owner there because there might be arguments among the team, and there might be arguments with the product owner, and those are not productive. So they should not be there. This should be, okay. This should be a safe space for devs to air their grievances. Okay, and if you've got business people there, it's not a safe space to do that kind of stuff. I grieve, G-R-I-E, grievances. Okay, so you can't do that if there's a business person sitting there, because they're not going to understand, and then they're going to try to apply all the business management stuff. Your Scrum Master should be versed in conflict resolution things, so they should be able to manage it. And the product owner being there is not going to be helpful. And in fact, they're going to be a major hindrance because people won't feel comfortable discussing things openly, and if they do, it might have unintended consequences, which are undesirable, because then people won't discuss things openly again. So product owner's not there. And that is the short version of Scrum. It's actually pretty close to the long version, too. I didn't skip anything. Nope, that was it. Okay. Product owner, the developer, as a blank, I want to blank, so that blank, good. User story cost estimate, the units are arbitrary. I should say this. Another part of the retrospective here, I haven't talked too much about the responsibilities of the Scrum Master. One of his responsibilities, I say he, it could easily be a she, is to make sure that everybody follows the rules of Scrum, right? That they have these meetings, that they run the way they're supposed to, that everybody's doing what they're supposed to do according to Scrum. Nobody has gone off book and is doing something totally different. But another role of the Scrum Master is to ensure continuous improvement. Okay, so during these retrospectives, things are going to come out like, what didn't go well? It was this. And then you have, how would we handle that differently? And then it falls to the Scrum Master to make sure that happens. Right, a lot of things will be self-responsibility of team members, like why didn't it go well? It's because I kept getting pulled away to work on another project. Right, that is not allowed under Scrum methodologies. Like a team is a team, and the team is a unit. Team members should not be pulled off the team, because one of the important elements of groups is that the group is defined. And if you ever have an undefined group, you lose all of the group properties. Like you can't manage them like a group anymore. So one of the things is called a real team. So everybody is on the team, and the team is the team, and all of the tasks belong to the team. So nobody gets pulled off. Okay. One of the other rules, I didn't get into all the rules, is that you're not allowed to add significantly changing things to a sprint once it's in progress. So once you decide these are the features we're implementing, you're not allowed to show up 3 days later and insert another one, or even to swap them, because that's not what we agreed to. Right, now, there's a caveat to that. Emergencies happen, and sometimes something needs to be addressed as an emergency, but that they should only be taken on an emergency basis. Right? It's not something that you want to allow to regularly occur, because then you lose a lot of the properties we're trying to get from following this method. So the Scrum Master's role, among other things, is to try to make sure the team keeps improving. And we can measure the improvement of the team quite easily through velocity. Velocity will be increasing over time. So our team might say, this went really slow because we got to always flip back and forth between our development environment and the API documentation. Everything would be really a lot better if we had 2 screens. If everybody had 2 screens. I think that's pretty standard now, but there was a time when it wasn't. And I remember those times I would bring, at the school, I had to bring my own monitor from home so that I'd have 2 screens. Like, the workstations provided by the college have a single screen. And as a developer, I know that I am tons more productive with two. So I got my dev environment on one, and then my API reference on the other. And I could even justify a third to say, all of the little command line boxes that run the application, those are on a third. Or it could be my web page, my web browser that is actually using the application I'm developing is on the third screen. Something like that. All right, so the developers might say we all need two screens. And then the Scrum Master will be of the mindset, okay, well, if I give you two screens, your productivity has to increase. And they'll be held accountable for that. So there have been cases where, companies had development teams that were not empowered. They were not allowed to do anything for themselves. And then there's a push from upper management to become agile. And then, the development team doesn't believe it because they've heard it before, but they know that this organization is very top-down and very heavy-handed in management, so they don't believe the autonomy they've been given. So one of their requests was, we want potted plants. And so, of course, the Scrum Master says, okay, I will get you potted plants, but your productivity has to increase. And it did, because, well, I'll tell you why. We haven't really talked about motivation. This will be the last thing I add. So where's our team? Did I ever have a section on the development team? I don't think I did. All right, so we'll put that at the very front. Oh, I remember talking about team size. Where was that? 2 pizzas. Does anybody remember where 2 pizzas went? Oh, it's down here for execution. Okay, so let's grab that. Put that on the team. I'll be done in the next, 5 minutes. I know I'm a touch over. Almost there. Come on. Okay, so team size. Okay. Not that big. So a real team. That means there's defined members and there's a defined boundary. So you can do research on team stuff. I don't have time to go into all team theory things, but we could talk for half a day about that. Okay, what was I going to add here? Oh man, what was I going to put? What was I talking about? I forgot. Ah, motivation, right. So there's really 3 factors in motivation. So psychology's studied this quite a bit, particularly in industrial psychology. So study of workplaces. So the 3 things are autonomy, mastery, and purpose. Okay, so autonomy I think is self-evident. It's you work as an autonomous person. You're not being micromanaged. You're allowed to make your own decisions. And there's a lot of autonomy in the Scrum framework. So when you're doing the development loop over here, you're working autonomously. You'll interact with team members, but the team is autonomous and you're autonomous within the team. When the development team is making cost estimates, the development team does that autonomously. The product owner can say whatever they want, but it ultimately falls to the development team to make that estimate. And each individual on that development team gets to make their own estimates. And if somebody says, I think it's going to cost 34 when everybody else thinks it's 8, we take the 34. So they have autonomy when they're working there. Mastery is you get to practice your craft. And you get to practice it and you get to develop and improve over time. And then the last one is purpose. There is actual meaning behind your work. So it's going to impact something. Depending on what you're working on, that could be different things, but it's actually of benefit to somebody somewhere. And that can be as abstract as you want to make it. Like, so if I'm building a library that is going to do A/B testing, I can think, well, my customer is going to be able to choose the best version of their landing page. So that's a direct purpose.